In this video laboratory, we will talk about types of heat and heat transfer. But before we explain and apply the theory, it is important to know what is exactly temperature and heat. Temperature is a measure of the average kinetic energy of a particle of a substance. The higher the temperature of an object, the higher its kinetic energy. Kinetic energy is a type of energy associated with motion. Heat may be defined as the energy in transit from a high temperature object to a lower temperature object. Heat is expressed in joules, and 1 calorie is equal to 4.186 joules. Now that we know this, we can continue with the rest. The specific heat is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius, and it is represented with this formula. Latent heat is when heat flows out or into an object, and it also can produce a change on its physical phase. This process will occur without a change in that temperature. Transfer heat is normally from a high temperature object to a lower temperature object. Heat transfer changes the internal energy of both systems involved according to the first law of thermodynamics. And there are 3 types of heat transfer. Conduction is heat transfer by means of molecular agitation within a material without any motion of the material as a whole. Convection is heat transfer by mass motion of a fluid, such as air or water, when the heat fluid is caused to move away from the source of heat, carrying energy with it. And radiation, which is the last one, describes the phenomenon of transition of energy from one body to another by propagation of irrespective of a medium. All bodies constantly emit energy by electromagnetic radiation. The intensity of such energy flux depends not only on the temperature of the fluid, but also on the surface characteristics. If you sit in front of a campfire, most of the heat that reaches you is radiant energy. Very often, emission of energy or radiant heat transfer from cooler bodies can be neglected in comparison to convection and conduction. Now it is time to prove and apply this theory in an experiment. In this case, we will make an ice cream with salt and ice.
For doing the ice cream, we need some ice, we need our flavor of the ice cream, and some salt. First of all, we're gonna see why do we need the salt. The reason why we need salt to make the ice cream is because when salt and water are mixed up, they produce an endothermic reaction. This means that it's a reaction that needs heat. So, in order to dissolve the salt into the water of the ice cubes, the ice and the salt need to gain some heat. And where does that heat gonna came from? It will came from the recipe in which we have our liquid that in some moments it will become our ice cream. That's why we need the salt. Now back to the ice cream production. We put our recipe in the middle of the ice. Now we need to add some salt and put it into the ice. Once we put the salt on the ice, we need to shake all this the enough time that the liquid becomes the ice cream that we want to eat. After a while we can see that the liquid is becoming even more into solid. In this case it's almost the consistent like the ice cream. We're very close to have the ice cream. After approximately 35 minutes we can see that our ice cream is already done and it's ready for us to eat it. All what's left is eat and enjoy our ice cream. We see some concepts and we also make our own ice cream. But how does it all relates? Well, let's begin explaining the relation with all this. Well, we have 2 objects that have heat. The first one is our mixture and the second one is the ice. The mixture has a greater heat than the ice. So what does that mean? That means that the heat would flows from the mixture to the ice. And this is like an example of making ice cream. We have 2 heat transmission.
One is conduction, that it gives when the recipe where we have our mixture touches the ice, the heat flows through conduction. And we also have convection. Convection, we had it inside of the recipe of the mixture. That's why we need to shake it in order that the fluid it is constantly moving and it's carrying the heat out so it can get cold faster. So if the heat flows from one object to another, then we have a changing temperature. So we have a specific heat. And but there will be a point in which the fluid, our mixture, will reach his max, well, his minimum temperature, and the ice will reach its maximum temperature. And that's when the ice is going to use the heat that gains from the mixture to change its state into liquid, and the mixture will use that lost heat to change to his state onto solid, and there's where a specific heat relates here. After doing the video, we reached the conclusion that heat is everywhere because everything is composed by molecules, and heat is how fast molecules move. We also conclude that heat transference is in everywhere because there will always be hotter objects than others, and if that happens, then the heat will flow from the hotter object to the colder. So if there is a change in the temperature, then we will have a specific heat. So we also have a specific heat or everything. And every time an object changes state, we will have latent heat. So we can conclude that heat we find it in every piece of the universe because heat is an energy, and energy neither created or destroyed, it is only transformed.